everyone, so in today's episode of Wacky Science, we're going to look at something that can treat 24 diseases, operate worldwide, and prevent us from disease. That's right, we're discussing vaccinations. Now, many of you would have encountered them by now, but do you really know how they work or how effective they are in fighting and preventing disease? Vaccinations all started back with a man called Edward Jenner, who was a bit risky but really creative and smart. Using inoculation, he inoculated an 8-year-old boy called James Fitz with a cowpox antigen to give him immunity. Now, this isn't your average game show immunity. We're talking about your body's ability to fight disease. So after James recovered, he was later inoculated with smallpox and he survived. Hooray! From this experiment, vaccines were created and revised until what we have today. Needles and oral vaccinations which help us fight disease. So how does the vaccination stop infection? Vaccines are preventable measures to minimize the dispersion of some infectious diseases. Vaccines can be a weakened or dead antigen version of the actual disease the vaccine is immunizing us from. Here is how vaccines work. The antigen is introduced into the body, then the helper T cells track down the pathogen and release cytokine, which activates the appropriate cytotoxic cells. Then these cells come and kill the antigen with specialized antibodies. This process could not have happened without memory cells, which memorize the specific vaccine disease so you can fight it when you next have it. You probably wouldn't even realize you had it, as there would be minimal symptoms. To further explain this, let's use the infectious disease smallpox. The virus known as the variola virus is the causative agent of the contagious infection smallpox. Now, there are two variants of the virus that cause smallpox. The first is variola major, which is the more serious disease and has a higher mortality rate, whilst variola minor is a milder form of the disease, also known as milkpox, whitepox, and cottonpox, and its mortality rate is much lower. This virus is transmitted in 3 ways. 1. Prolonged close face-to-face contact. 2. The spread of saliva drops from sneezing, coughing, or speaking. And 3. Contact with sheets or clothing that have been infected. When a person has smallpox, they would notice symptoms. These include small blisters that can cover the face, including the throat, mouth and eyes, limbs, and the rest of the body, that will fill up with pus and will eventually scab over. Flu symptoms are also a sign of smallpox, accompanied by a rash that gets worse over time and will eventually turn into the smallpox blisters. Now we are going to look inside the body to see what the immune response does. The body's immune response to the variola virus is quite interesting because of the persistence of the poxvirus family. The poxvirus family has a protein called an interferon gamma binding protein, which we are going to call IgBP for short. This protein activates once the virus is in the bloodstream and basically does what the name says. It stops the cytokine interferon gamma being secreted, which enables the virus to replicate and spread. When IgBP is not present, T helper cells can activate antibodies that divide to rid the body of the virus. That's why when we have smallpox, IgBP causes the virus to grow and multiply quicker. To help us fight smallpox and the 23 other diseases, we have public vaccination programs. Believe it or not, public vaccination programs started with the smallpox vaccine. Although this vaccine was created in 1796, it was the first mandatory vaccine all school-age children required in 1922. Since then, vaccine programs have been initialised to reduce the amount of vaccine-prevented disease cases. For example, the current Australian vaccination record involves shots starting at 2 months and every 2 months until 12 months old. These vaccines are designed to protect young children before they are likely to be exposed to potentially serious diseases when they are most vulnerable to serious infection. There are also more shots at 18 months to 15 years old. Following all the mandatory ones, there are also some for individual preference, such as free shingles vaccination for 70 to 75-year-olds and the optional annual flu shot. Vaccination programs have enabled numerous people immunity from disease, and in some cases like smallpox, whole diseases have been eradicated from society. The programs have also prevented disease for the vulnerable of society due to herd immunity. This acts as a barrier and protects the individual, but also the people who are unable to be vaccinated, keeping society healthy and free from VPDS. Though not always accepted due to the skeptics around vaccines, people now know the ability vaccines have to eliminate preventable diseases and protect the greater health of society. So how effective have vaccination programs been worldwide, you may ask? Well, vaccination programs have played a vital role preventing the spread and occurrence of once common diseases, including smallpox, polio and diphtheria, just to name a few. Stated by the Australian Immunisation Program, vaccinations have been demonstrated to be one of the most cost-effective public health interventions, preventing approximately 2.5 million deaths each year. Majority of the people who have access to vaccinations get them because of policies for school or daycare requirements, and because they know the benefits of vaccinations. However, there are still some individuals who can't be vaccinated or won't be vaccinated. It can be for a variety of reasons. The individual may not be able to because of allergies or other health reasons. There are also some people who won't vaccinate due to health scares such as getting autism from MMR vaccinations. However, most suspected vaccine-caused conditions occur due to pre-existing cells within the body that cause illness or sudden medical events that coincidentally happen around the same time as shots. One of the goals for vaccination is to eradicate specific diseases from the globe and to prevent the spread and occurrence of vaccines. Eradication must be achieved or on the path to being achieved. To be completely eradicated, WHO states eradication requires a high level of population immunity in all regions of the world over a prolonged period with adequate surveillance in place. Vaccinations are used globally. They can eradicate disease such as smallpox. The World Health Organization was in charge of running the global effort to eradicate smallpox, and with global mandatory vaccines, it was announced on the 8th of May 1980 it was fully eradicated. The last epidemic of smallpox was in Somalia in May 1977. This demonstrates the effectiveness of vaccination efforts when a disease can be eradicated only 3 years after its last epidemic. Polio is another example of a disease that is effectively being eradicated. There are 3 strains of poliovirus, and type 2 was eradicated in 1999. The WHO are partners with the Global Polio Eradication Initiative, aiming to reach everyone worldwide with a vaccination, especially to the 3 most prevalent polio countries, Afghanistan, Nigeria, and Pakistan. The elimination of polio is 99% complete. The Australian immunisation program stated that smallpox eradication and polio near eradication were model examples of disease control through immunisation. Diphtheria hasn't been eradicated yet, but in Australia there hasn't been a case since 1992. Currently, only local elimination can be achieved, like in Australia, Europe, the USA, and the UK. Vaccinations and improved living conditions have resulted in this disease's rarity. Although diphtheria has resurfaced in some countries, such as South America in 2015, when a child died from it, this occurred due to not receiving the booster vaccine. Some vaccines rely on the booster shot to provide complete vaccinated immunity, and the booster once older as it affects adults more. Therefore, in this instance, the effectiveness of the vaccine was unsubstantial because of the amount given. The Australian Department of Health also states that diphtheria could re-emerge in Australia if immunity were not to be maintained, showing the importance of continual immunisation against not yet eradicated disease in all countries to be effective worldwide. The overall effectiveness of vaccines has been progressing, and once common diseases are becoming less widespread. Smallpox and type 2 polio have been eradicated as a direct result of vaccine persistence and global monitoring. Diphtheria is being eliminated region by region. However, booster misuse has caused resurgence of this disease. Overall, vaccine programs need to be available globally and actively monitored for them to be completely effective in preventing and eradicating diseases in the future. Thanks for joining us today and learning about vaccines. See you next week. Bye!